Has your younger brother or sister ever repeated every word you said right after you said it? Have they copied almost everything you do to a T? How many of you have yelled, "Stop mimicking me"? Well, it's not just younger siblings that exhibit mimicry. It happens in nature too, and quite often. Mimicry is a morphological and oftentimes behavioral resemblance between two species that allows an organism to trick both predator and prey. Organisms that evolve to portray characteristics of another species are called the mimics, and organisms being copied are called the models. There are two main classifications of mimics: defensive mimics, which evolve to appear like a poisonous or venomous species to deter predators, and aggressive mimics, which evolve to appear like harmless species in order to draw in prey. It is important to make a distinction here between aggressive mimics and camouflaged ambush-type predators. Camouflaged ambushers want to remain hidden from their prey's perception as long as possible by blending into the background, while aggressive mimics actively want to be seen by prey and convince them of their harmlessness so as to draw them in closer. Mimicry evolves in multiple ways, but most often begins with a large mutation that provides a significant benefit to the new variant. In most cases, this first mutation provides the mimic with the defining characteristic of another reputable organism in the ecosystem. As generations go by, the mimic further refines its characteristics until it is, for all intensive purposes, indistinguishable from the model. Hymenopus coronatus, more commonly known as the orchid mantis, gets its common name from its resemblance to an orchid. In comparison to other species of mantis, which are commonly brown or green, the orchid mantis has a strikingly different physical appearance. The orchid mantis is often white or pink as a juvenile, and is generally white as an adult. The femoral lobes of an abdomen of an orchid mantis are round and petal-shaped as compared to the long, thin abdomen and appendages seen on other mantises. Behaviorally, the orchid mantis has also developed a preference to position itself in unobscured places apart from other flowers and bright colors that would decrease its chances of being seen by a pollinator or insect. After viewing this striking behavior and morphology, researchers James Hanlon, Gregory Howell, and Marie Herbertstein began to speculate that the orchid mantis may be displaying a rare form of aggressive mimicry. To begin testing this hypothesis, researchers gathered a variety of colorimetric and morphological data on wild orchid mantis specimens for comparison against regional flowers. In the first round of data collection, the researchers studied whether a pollinator species would be able to distinguish between the coloration patterns of an orchid mantis versus a flower. Using a portable spectrometer, color data was measured for 14 wild orchid mantises and 13 different wildflower species known to exist in the mantis's natural habitat. This spectral data was then organized into hexagonal chromaticity and Maxwell triangle chromaticity diagrams, where black triangles represent the orchid mantis data and white triangles represent the average flower color in the region. These diagrams show that through the eyes of a pollinator insect, an orchid mantis is essentially indistinguishable from a native flower. In a subsequent study, the researchers also performed a geometric analysis of the orchid mantis and the wildflowers. Measurements were taken out of the femoral lobes and abdomens of the orchid mantis and compared to the petals and sepals of wildflowers. This diagram shows the results of the morphometric analysis. The orchid mantis possessed some similarity to many of the flowers, most notably the melastoma. However, it is not a perfect mimic of any one flower, since even melastoma possess differences such as radial symmetry and nectar guides. The researchers proposed that the lack of resemblance to any one flower species is likely due to a relaxation of selection pressure, since the mantis must only attract a pollinator within a certain inspection range. In a final experiment to confirm the efficacy of the mantis's mimicry for prey attraction, the researchers placed captured mantises on top of sticks in an open meadow and observed the number of pollinator inspections each mantis received. For controls, data was also recorded for pollinator inspections of a bare stick, as well as a lone flower mounted on a stick. The data obtained not only showed that mimicry was effective, but that the mantises actually received more inspections than the control wildflower. It is from these sets of information that the researchers concluded that the orchid mantis is in fact an aggressive floral mimic. In review, mimicry can evolve for either defensive or aggressive purposes to provide an organism with a selective advantage, as seen in the case of the orchid mantis. And finally, for your viewing pleasure, here is a video of an orchid mantis in action.
Created using Powtoon.